The discovery of quarks. An internal structure of nucleons, that is, protons and neutrons, consisting of 3 quarks, had been predicted in 1964 by Murray Gell-Mann and independently by George Zweig. Incidentally, it's Murray Gell-Mann that came up with the name of quarks. In 1968, scientists working at the Stanford Linear Accelerator, or SLAC, were bombarding protons with very high energy electrons and measuring the energies and the angles of the scattered electrons. Their findings matched the model of 3 quarks. The protons and neutrons were no longer considered fundamental particles. They had an internal structure. We're going to look at a couple of simple animations to get some idea as to the experiments they carried out. First, to look at what is meant by an elastic collision. The small blue ball here is representing an electron which will collide with the larger proton, like this. Considering the kinetic energy of the electron at the start, and the kinetic energy of the pair of particles at the end, we would find that the kinetic energy before the collision is equal to the kinetic energy after the collision. This is what makes this an elastic collision. There is no loss of kinetic energy. This is like perfect snooker balls would be. Now an inelastic collision. The electron comes in, but now there is a loss of kinetic energy. So the kinetic energy before the collision was greater than the kinetic energy after the collision. This can only happen if some of the energy is contained within the nucleon. For this to happen, the nucleon, the proton here, must have some sort of internal structure to hold on to that energy. This situation is a little bit like if you drop some soft dough onto the floor. Kinetic energy would be lost and it will find itself as some heat in the dough itself. These experiments were known as deep inelastic scattering. They went deep into the nucleons. They were inelastic as there was a loss of kinetic energy, and the electrons were scattered, and scientists were able to measure their kinetic energy and angle and make some deductions from this. There are clear comparisons between this experiment and the Rutherford scattering that discovered the nuclear atom previously. This table sets out to highlight some of the similarities and differences between the two experiments. Firstly, the target. Both experiments were firing things at a target. Rutherford was firing at gold atoms. Deep inelastic scattering was firing at nucleons. Now the object being fired, the bullet. Rutherford fired alpha particles. It's all he had available to him at the time. Deep inelastic scattering fired very high energy electrons, having been accelerated by the Stanford Linear Accelerator. The collisions in the Rutherford experiment, they were elastic collisions between the alpha particles and the nucleus. Deep inelastic scattering had inelastic collisions between the high energy electrons and the nucleons. The findings. Well, Rutherford discovered a small, dense, positive nucleus. Deep inelastic scattering found a nucleon structure made up of 3 quarks.